Okay, here we go. Hi folks, my name's Penny. I've been at Atlassian for about 5 years now, and I work as a QA team lead for the Jira and Service Desk teams. Before I was at Atlassian, I spent 7 years as a developer, a dev in test, a tester, moving back and forth between those two domains. So let's talk about just the Jira team. So on Jira, we've got about 70 developers spread across three companies and 3 countries. So these are pretty amazing folks, and they ship high-quality releases every 2 weeks to our customers. Now, if we were following traditional quality assurance practices, in order to do that, we'd need an equally large test team of 70 testers. But instead, what we have is a QA team of just 6 people. And of those, only 5 do any work. I just sit around and go to conferences and stuff. So today I'm going to talk about 2 things. First of all, I'm going to talk about why we do it this way. We really care about quality. So why do we have a smaller QA team in order to get more quality? And then I'm going to discuss how we did this and talk about quality assistance. So let's start with the why. Quality at speed. So speed, scope, and quality. It's this triangle of trade-offs. You've probably seen it in many different forms. Sometimes there's time instead of speed. Sometimes cost is in there too. But the underlying assumption is held true in many places, which is that if you want to ship faster, you have to cut either scope or quality. What does that look like in practice? Well, in a waterfall team, it's something like this. You do your development up front. You pass your code over to the testers who test it. What a surprise, they find bugs, they bounce it back to the devs who fix it, and eventually once you've fixed enough bugs, you can cut a release and ship it to your customers. That's in theory. In practice, you get deadlines, time pressures, and what do you know, that release bar comes a little bit earlier, and there you are, you're getting increased speed but reduced quality. If you're really unlucky, you can end up in a situation where you release it just after development. Anyone been there? I know I have in a previous life, yep. So in Agile, it's a little bit different. Your development and bug fix and testing is all happening in parallel. So this means that you can't cut quality just by moving that release bar. You're actually cutting scope instead. Or at least in theory. Again, in practice, you can end up in a situation where you do all the fun development work up front. You develop this pile of bugs that you say, oh, we'll fix that later in a hardening phase or a polishing phase. And then real-world pressures come in again, and you're back to shipping poor quality software. So at Atlassian, we weren't really that keen on replicating any of these patterns. So instead, we sat down and had a look at the assumptions underlying all 3 of these models. And they're all based on the basic idea that you build something incorrectly, then you test it, you fix it, and then you ship it. Why are we doing that? Well, somewhere they got baked in this idea that the skill of building something and knowing if what you built is any good, these 2 sets of skills are separate and belong to 2 different classes of people. Because if your developers were all equal to the most skilled testers that you've ever worked with, your release cycle would just look like this. You'd build it once correctly, and then you'd ship it. End of story. So why aren't most people working this way? Or more tellingly, why aren't most people even trying to work this way? Why is this not held up as the ideal for major software projects? Well, the reason is, basically, to be honest, your average developer, not everyone, but your average developer isn't a very good tester. Testing is a skill, it's a mindset, it's something that takes time and effort to develop. And if nobody's teaching developers this, then they're not learning it. What we're seeing more often these days is with Agile teams where you have no QA or testers and the developers are doing TDD, because they're doing all the testing, they start to believe that that makes them good at testing because they've never actually seen anybody doing a good job at testing. So they think that just writing hundreds of unit tests means that the software is high quality. So all of this comes down to when an average developer sits down to test their own code, it's not so much breaking it and more this kind of scenario. Yeah. So how do we end up this way as an industry? Well, let's go back to the 1960s, where there was an episode of Star Trek where Captain Kirk, dashing and heroic Captain Kirk, went through a transporter accident. And he split into two people, each only with half of his personality. So one side was meek and timid but moral. The other side was evil but decisive and got stuff done. Now, the two of them as one person, he'd been a very moral, very decisive, very effective captain. But as two different people, it was a disaster. They fought with each other, they fought with everybody else, they put the ship in danger. Now, my theory is that round about the same time, a software engineer went through the same accident, and they split into separate dev and tester halves, each only having half the skills they needed to produce great software. So once this engineer was released from sickbay, the dev side went back to work in engineering. But things weren't quite the same as before. So first of all, they lost their quality mindset. They started giving weak excuses for delivering poor quality stuff, rather than really caring about what customers needed. Secondly, they lost their testing skills. They started thinking that automation was the solution to everything, that just testing on their own box was the same as production. And then they lost their knowledge of how the product works, how customers use it, various types of other risks such as security and performance, and they stopped learning from other people's mistakes. So in desperation, the chief engineer went out and found the tester half who was still wandering the corridors of the ship and put them to work side by side with the dev half. But now that they were two separate people, they started fighting with each other, bouncing work back and forth between themselves because they had different goals and different mindsets. So, is there hope for the future of the software industry? Can we recombine these two people back into one again? Well, the good news is that there is hope. So the missing mindset, that can be affected by the culture of the team in which the dev is working. Missing skills, missing knowledge, both of these can be fixed through education. And so you can combine a dev and a tester back into a single person again and have this ideal release process. And once you have that, then you no longer have this speed versus quality trade-off. What you're doing is eliminating waste and rework and spending all your time just on development. How do you do this? Well, this is where quality assistance comes in. So although my title is Senior QA Team Lead, that QA stands for Quality Assistance. And what that means is that I'm not a tester. We don't have any testers at Atlassian. We don't hold the ultimate responsibility for the quality of what's shipped. The people who do the work have that responsibility. And it's our job to help them meet that responsibility. So in the short term, we do activities that help protect our customers, protect you folks. So making sure that everything that goes out the door is production quality. But we always do that with this long-term goal of giving our developers this mindset, skills, and knowledge so that they can do their own testing, so that eventually we'll be obsolete and I can go and lie on a beach for the rest of my life. So before I get into the details of how we do that, I'll just take a moment here to acknowledge that some of you might be feeling a little bit skeptical about this right now. Come on, hands up. Okay, good. So at this point, I'll admit that when I first joined Atlassian 5 years ago, I didn't believe this could work. I'd just spent 3 years working at Microsoft with what everybody told me were the best developers in the industry. And everything they passed to the test team was broken in some form or other. So I believed that developers and testers were two completely different classes of people, completely different mindsets, and that you couldn't teach a developer to test. So I spent a good 2 years or so arguing with my boss about this. Thankfully, he had a bit more vision than I had. But we didn't actually know how we were going to do it. We just had this broad vision. So we experimented. We tried a lot of things. Some things worked and some things didn't. But over time, as I started to see it make an impact, I started to see it working, I became a true believer. So how do you measure something like this? Well, my favourite metric is what I call story rejection rate. That is, the percentage of stories that have to go back to the original developers for some form of bug fix or rework once it's left their hands. So when we first introduced QA on the Jira team, the rejection rate was 100%. Every story had something wrong with it. Generally it was good, like it was functionally correct, but there were security problems or it didn't work on one browser in one situation. But over time, as we go through the process that I'll explain in a minute, this rejection rate has fallen and fallen. And the best we've seen across a whole Jira release was 4%. So that means that in that release, 96% of stories were coded and tested to production quality standards by the original developer. And that's a pretty amazing transformation. So, how do you go about making such a big cultural change? Well, it's not easy. It took us 5 years in Jira, and we're still working on it. So to begin with, the Jira team ran for 8 or so years with no QA at all, just developers. And they were doing TDD, they were writing all their own automated tests. But they were solely focused on automation. Now, don't get me wrong, automation is a critically important part of the quality picture, but it's not the whole picture. Automation can't tell you whether a new piece of functionality is robust, whether there are edge cases that could break it. It won't tell you whether it's secure. It won't tell you whether the performance feels good. It won't tell you whether it's intuitive to use. Automation can only really answer questions for which you can list those questions in a checklist. So the first thing that we did was just to show the developers that there was more to testing. So what we did was we sat down alongside the developers and took on a traditional testing role. So we started doing exploratory testing of every story that they completed. And as you saw from that 100% rejection rate, we were finding problems with everything that they were doing. So by doing this, first of all, we were learning the product, we were learning the patterns of issues that were going wrong. But also we were earning the developers' respect. So after a couple of times where we saved their asses from shipping horrible issues to production, they started realizing there is actually something to this testing skill that we don't know here. And they started listening to us, which made a nice change. So then, having got that buy-in, we started pushing things back on them. And we introduced what we call dotting, or developer on test. So this is where each developer would test another developer's story once it was done. So as we still didn't really trust them very much, the highest risk stories were still picked up for QA for testing, but everything else went to another developer for dotting. And as another level of distrust, we also were privately doing release testing of each new release before it went out to the customers, just to see if any issues had slipped through the dotting stage. Now, I'll be honest with you, this stage of things didn't really work that well because, as I previously mentioned, developers, as they came into us, were not that good at testing. So what we found were we were finding huge numbers of issues at that release testing stage, which was blowing out our release process. So we threw that away and we tried something different. We said, okay, let's really invest in dotting and make sure that it's done well. So we said, from now on, we're going to take a big bet. QA is not going to do hands-on testing of any stories. From now on, dotting is the only thing that's happening. And with the time that we saved from that, we invested that into giving developers more education in how to do dotting well. So we introduced QA demos. So after the original developer has finished implementing the story, we sit down with them and have a 15, 30-minute discussion with a QA engineer. And we talk about what they implemented. We have a bit of a poke through the UI, but we're not testing it. We're just trying to understand what's changed. We have a look at the code changes. We look at how they've implemented it. And we talk with them about what risks there are, what they're confident about and what scares them, and what testing they've already done. Now, any skilled QA engineer from that would already have a pretty good idea about what things they would test if they were going to test it themselves and what bugs they're going to find. Very often you could predict the bugs that you could find based on that discussion. So instead of doing the testing ourselves, what we did at that point was write up testing notes on the issue. Now these are prompts and hints for the DOT to use when they're doing their exploratory testing. Now an important thing here is that they are not test cases, they're not checklists. They're not instructions for what the dev should do when they're testing. Because that's the best way to ensure that the dev is just going to switch their mind off and go tick, 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 right. You may as well just write automation for that. What we wanted to do was encourage them to do critical thinking to explore. And so the testing notes are open-ended. They're things like, see if you can get the data into a corrupt state. See if there's some way you can bypass this security check. See if there's problems around time zones. Open-ended questions to get them thinking about potential risks and things to explore. And we found by introducing these demos and the testing notes that the quality of dotting rose dramatically. And after 6 months of doing release testing where we weren't finding any issues in the release testing stage, we just dropped that stage completely. It was no longer necessary. So that was good. We got the quality to where we wanted it. But then we wanted to focus on speed. One thing we identified was that many of the issues that were being found by the DOT were issues that we'd already known were going to be there. You know, you get one developer and every time he writes a new feature, he forgets to test for session timeouts. So you tell the DOT, test for session timeouts. He'd say, session timeouts are broken. You say, I knew that. So at this point, we realized we were telling the wrong person. Why are we telling the DOT that? We should be sitting with the developer before they start work and telling them, hey, make sure that you make session timeouts work. So at this point, we introduced QA kickoffs, where the dev and the QA sit down before work starts and discuss the risks. It's one of these things that's obvious in hindsight, but for some reason it took us several years to actually think of that. And just from introducing QA kickoffs, the rejection rate halved from 30% to 15%. The next thing was we still want to keep pushing back to the developers that thinking through these risks is their responsibility, not ours. So once developers got into the habit of doing good QA kickoffs, we started getting them to do them by themselves, write up their own testing notes, and then we'd review them. And that gets us a bit more out of the process, gets things a bit more owned by the developers themselves. Then eventually we got to the stage where we found that the presence of the dotting safety net was actually hindering our improvement. Because the original developers were starting to be a bit slack about their own testing because they knew that another dev would be picking up the slack after them and testing for them. And these are devs that were doing diligent work testing other people's stories, but as soon as they turned to their own, no way, there goes all the diligence. So we got tough. We said, right, from now on, in certain teams, we're going to drop dotting completely. You are the last person to see your story before it goes to production, so you'd better be very careful that you're testing it correctly. So we still had the review of the testing notes, we still had the QA demo to keep an eye on devs, make sure that they were meeting this responsibility. But we found by dropping that dotting safety net, the quality of the original developers' testing rose dramatically. And so that is the current default process in Jira for development. The developer does their own kickoff, we review their notes. The dev does the coding and the testing, we have the demo, and then it's done. It goes to production in the next release. Now I'd say current process and not final process, because this is something we're consistently working on. We're always looking to change, always looking to improve. And we still have that 4% rejection that we want to get rid of. And so for this group of developers, we have actually been able to put the two halves back through the transporter and reintegrate them back into a single engineer again. And along the way, I've been converted as well. So I started off as a cynical QA engineer who wouldn't trust a developer as far as I could throw them, which isn't that far. But these days, I have ultimate faith in our devs that they are equivalent to the best testers out there in the industry. And so when I said at the start that we don't have 70 testers on the Jira team, I actually lied, because we do have 70 testers. They're just the same 70 people as our developers. So the takeaways, So the first one, the lesson that it took me so long to learn, is this idea that real software quality actually comes from improving people. If you work on code problems, then tomorrow you will have new code problems. But if you work on people problems, then tomorrow you won't have those problems anymore. Secondly, major world-changing improvement comes from actually questioning the assumptions underlying the way that you're working. That's where you can really see what's making a difference and what you can change. Third lesson is to experiment. So the process that I've taken you through here, don't go away and apply that to your own teams. That's what worked for this team in this company at that time under those circumstances. The lesson I'd like you to take away is to experiment with your process, take some risks, find out new ways of doing things and improve. And have fun while you're doing it. You may as well. Thank you very much.